If this is in equilibrium, does it mean that this section is also in equilibrium?
Yes, sir.
Naturally. This section is also in equilibrium. So it means every part is in equilibrium then. Okay. So let's start. It says here method of section. We did method of joint to find the forces on members. Now we're going to do method of section so that we can find the force in the member using this technique also. I mostly use method of joints, but wherever we get stuck, you can use method of section. So when we need to find forces in only a few members of the truss, we can analyze the truss using method of sections. It's a very vague statement. You use method of joints also when you look at the section. But anyway, method of section is based on principle that if the truss is in equilibrium, then any section of the truss is also in equilibrium. If the whole stuff is in equilibrium, every part, small part, every member, every joint is in equilibrium. Okay. Now we can cut a section. We can cut or section the members of an entire truss. Draw the free body diagram of either of its two parts, and then apply the equation of equilibrium. I'll show you that. Don't worry. We should try to select a section that, in general, that's a very good one. This is, you have to remember. Okay, this is very important. We should try to select a section because look, if I've got a, I'm looking at, let me get rid of this. Sorry, just a second. So if I am looking at this, I'm looking at this, and I cut it off. It says we should try to select the section. Which section you're going to select? This one or this one? So it says here we should try to select a section that, in general, passes through not more than 3 members in which the forces are unknown. If I cut it like this, how many members are cutting off? 1, 2, 3, 4, 5. That's not the right way of cutting the section. If I cut it in this way, I'm just cutting 2. What it says here, we should try to select a section that, in general, passes through not more than 3 members, not more than 3 members which the forces are unknown. So you can do it here, or you can do it here, but it should not be more than 3 members. So 4, how can I do 4? 1, 2, 3, no. 1, 2, 3. 1, 2, 3, 4, 5. I can get 4 anyway. So this is the right part of section if you got 3 unknown. So we'll do some example and we'll get clear. Don't worry. Cuboid diagram. Make a decision on how to cut or select or cut or section the truss to the members where forces are to be determined. I will show you this. Okay. Before isolating the appropriate section, it may first be necessary to determine the truss support reaction. Sometimes, remember, sometimes you can't find the unknown forces inside, so you need to get the cuboid diagram of the whole system, get the reaction forces, and then you start your analysis inside, just like in the method of joints. If this is done, then the 3 equilibrium equation will be available to solve the member forces and section. Don't wait, because basically, it depends on the problem. So draw the cuboid diagram of that section of the sectioned truss which has least number of forces acting on it. So when you select the section, where you've got the least number of forces. Again, when you do some examples, it will get clear. Use one of the 2 methods described above to establish the sense of unknown member forces. If you've got 2 forces acting in horizontal x in the left direction, then the third one will be in the right direction. towards the right. So moment should be summed about a point that lies at the intersection of the line of action of unknown forces, so that the third unknown force can be determined directly from the moment equation. This is exactly what I mentioned when I was solving problems, that you take a moment at the point where you've got the maximum unknowns, so that those unknown values do not appear in your equation. And we'll see that when we do an experiment and a problem. If two of the unknown forces are parallel, forces may be summed perpendicular to the direction of these unknown to determine directly the unknown. This is childish thing. You've got forces acting here and here. You do sum of all sorts of y, you get this one out. So don't worry. This is, you've already done this.